Okay, having a wee look at this here one. Into partial fractions first of all. So the top is x squared and the bottom is also x squared. So the first thing I've got to do is take the top and divide it by the bottom. The bottom is x squared minus x, add 3x is 2x minus 3. X squared into x squared goes once. 1 times the divisor. Draw your line, subtract. X squared minus x squared is gone. Nothing. Minus 2x is minus 2x. Nothing. Minus is plus 3. So I'm going to rewrite my expression as 1 plus the remainder over the divisor. Now, this is the bit here I'm going to put into partial fractions. So I'll go over to the side. Minus 2x add 3 over x add 3, x minus 1 equals a over x add 3 plus b over x minus 1. So sorting out the tops equals a over x minus 1 plus b over x plus 3. Choose x to be 1. So you get minus 2 add 3. That disappears for b. So b is a quarter. Now choose x to be minus 3. So minus 2 times minus 3, 6, add 3 is 9. Minus 3, take away 1 is minus 4a. So a is 9 over minus 4. So my whole expression is 1 plus a, which is 9, minus 9 over 4, x add 3, plus b, which is plus a quarter, x minus 1. And I want to integrate that. So I like to split my integrals up. So bring that out as minus 9 over 4, 1 over x, add 3 dx, plus 1 over 4, and bring that out to the integral sign. Okay, so to integrate 1, it just goes back to x. Integrating the fraction, do you have the derivative on top? Yes. Integrating a fraction, do you have the derivative on top? Yes, so just log the bottom line. You had limits here of 3 and 2. So putting in 3, so it's going to be 3 minus 9 over 4 log 6 plus 1 over 4 log 2. Then sub in 2. So it's 2 minus 9 over 4 log 5 plus a quarter log 1. And just putting that into the calculator. So 3 minus 9 over 4 times log 6, close the bracket, plus a quarter times log 2, close the bracket. So for the first one, I get minus 0.85817. Take away the second bracket, just putting everything into the calculator. So it's times log 5. Just take your time when you're doing this because it's very, very easy to make a mistake. And log 1 is 0. So it's minus 1.6213. And working that out, I should get an answer of 0.763. Okay, so that was the first one. Got to go to question 10 now on that paper. And it's asking you to integrate a log, which you can't do. So you've got to do the integration by parts. So u is that bit, dv by dx is the other bit. So do the reverse. So differentiate this, integrate this. To integrate that, you add 1 and divide by it. That's the same as 2 root x. So write out your right-hand side of your formula. So it's u v minus v du by dx is 1 over x dx. So tidying this up, 2 root x log x minus 2. That is x to the half over x to the 1. So subtract the indices. 1, sorry, a half, take away 1 is minus a half. Add 1 to the power when you go to integrate that. So it's a half and divide by it. Dividing by a fraction, same as turning it upside down, to give you minus 4 root x at c. Part B, it's telling you to use substitution. So you have got u equals the square root of x squared add 4. Just put to the power half. I've got to differentiate that. To differentiate a bracket, the power goes to the front, take 1 away, and multiply it by the derivative of the bracket. So when you differentiate that, those 2's cancel off, you're left with x over the square root of x squared add 4. Now if you rearrange that, you get du, just bringing that dx over, equals x dx over x squared add 4. Rearrange it to get dx on its own to sub in over here. So du times x squared add 4 over x equals dx. I'm going to take that dx and sub it in now. Remember your limits are in terms of x's. So you've got x 3 over x squared add 4, so I think stuff will cancel off. So your dx is now du x squared add 4 over x. You can see where they cancel, leaving you just an x squared. So your integral becomes x equals 0, x equals root 5, x squared du. Now if you look up here, x squared is u squared minus 4. So I'm going to write that as u squared minus 4 du. I've got to fix my limits now. So if you can just use it up here. If I put x to be 0, 0 plus 4 is 0, u squared equals 0, so u squared equals 4, so u will equal 2. And again, if you put in root 5 squared is 5, add 4 is 9, u squared equals 9, so u equals 3. And now the sum is good to go. So add 1 to the power, divide by it. The u reappears, and you've got 3 and 2. Substituting in 3. 3 cubed is 27, divided by 3 is 9. Take away 12. And then it's 8 over 3 minus 8. And if you just plug those into your calculator, you will get 2 1/3. Okay, number 11 of this paper. To find where they intersect, you've got to set them equal to each other. And what I'm going to do here is I'm going to divide everything by cos 2x. So I'll be left with sine 2x over cos 2x equals 1. So sine 2x equals 1. So 2x equals inverse tan 1. So if you think of your wee cast diagram, you've got CAST in here and in here. Your basic angle is inverse tan, which is pi over 4. So to give your two answers, 2x is pi over 4, and the other one is pi plus pi over 4, 5 pi over 4. So x is pi over 8 and 5 pi over 8. Now I want the area. So it's the sine curve. If you look, you can see it intersects the axes at 0, 0. So that's how I knew it was a sine one. So the area is integrating between pi over 8 and 5 pi over 8 of these two. Now, I like to see it separate. So sine 2x dx minus cos 2x dx. Where did sine come from? When you differentiate, cos goes to minus sine. So we need a minus and balance it. Derivative is a 2 and balance it. So when I integrate it, it's going to go back up to the cos. Where does cos come from? Well, a sine goes to a cos, so no sines to worry about. Must have the derivative in front, balance outside. Now it will go back to sine 2x. Putting in your limits. And what you're going to do now is just plug in minus a half cos 10 pi over 8 minus a half sine 10 pi over 8. First one, take away minus a half cos 2 pi over 8 minus a half sine 2 pi over 8. And if you work your way through that, you should, I'll just do it here actually. So it's, make sure your calculator is in radian mode. First of all, that's the first thing. So cos 10 pi divided by 8 times it by minus 0.5 gives me root 2 over 4. So sine 10 pi divided by 8 times it by 0.5. That's a minus, so that gives me plus root 2 over 4. That's the first bracket. Take away, working out the second bracket there. So it's cos pi over 4 times minus 0.5, which gives me minus root 2 over 4. Take away, so sine pi divided by 4 times it by minus 0.5 is minus root 2 over 4. So I have 2 root 2 over 4, take away minus 2 root 2 over 4 becomes a plus. So 2 root 2 over 4 plus 2 root 2 over 4 is 4 root 2 over 4, which is root 2. Okay, the last one. I want